Hi guys, it's Reed again. Sorry for being a little bit of a mess today, but I just wanted to continue to document some of the stuff I've done in the past for preservation. And today I wanted to show you guys this bird I did for temper, and this was specifically for Dr. John Halferty for his ECE 3612 class. And this is something I did a few years ago, and we kind of did an update piece for it to add some additional functionality. So basically, there's a board down here. There's a square one right here. It has it's a ATmega 324PB explained board. And it has an Atmel 8-bit microprocessor in it, and a JTAG with a micro USB port all inside. And the boards I made is this connector board here to jump from here to here. This breakout board down here, which has all your pins organized. So one second. So you have port A 0, 1, 2, 3, 4, 5, 6, 7, B, C, D, E. Over here are some LED selector switches, so you can control these LEDs or the 7 segment based on this. We have a analog potentiometer, which you can read back here and twist it with a screwdriver. Down here is a DC motor drive. So basically, we have an opto isolator, a diode, and a transistor, and you can drive a motor, and you have to apply external power for that. And I think they typically do like 12 volts. So this, you apply external power, and then you plug in your motor. That's that. Over here is one for a stepper. So we have a special stepper that they plug directly into these pins here. And again, you have to apply external power for this. We have some other headers here for other stuff they can do. We have dip switches, which they can use to read. And that's about it for down here. So in class, they basically do, projects to write C and assembly code to export LED, to write LEDs and do this and that and the other thing. They do interrupts on here. They do timers, stuff like that. More recently, this is a board that I completed. When were these finished? Maybe a year ago? No, 6 months ago, let's say. And here we added in a Hall effect sensor. This is like a magnetometer, a 3-axis one. Here is a gyroscope accelerometer, and here's a joystick. It's not analog. It's just a 6-way button or 5-way button. I'm sorry. And this is a temperature sensor. And we have a little LCD screen too. And all of these are I2C devices. I also put in a connector for a battery pack they have, so you can plug in a battery pack and run the board off a battery. So anyway, let me just show you a little demo program I have. Plug it in. So here's a demo program. You can see here the first couple of digits up there. They're kind of flashing because of the way the code buffers the screen, and that could actually be avoided if I buffer it better. You can see the strobing, that's it being updated, and that only appears on the camera. I don't see that in person. And then if I hit this switch, I can see. So here at linear, here's angular acceleration, and then let me show you the screen. Let me go File, Open. I think this project is a good one. Let's see how it compares. Oops, focus. Yep, okay, it's running. So here, you can see we have a readout of stuff. Oh, this is not the project I wanted. But anyway, we got some temperatures. So we're getting 5,800 counts on TMP 75 count. If I put my finger on the device down here, we're up to 7,000 counts almost. Yeah. I pull it off, it goes back down. These devices over here, because I think they're MEMS devices, they also have temperature sensors built into them. So the IMU temperature right now is at -45. I put my finger on it. Goes up to 10. And magnet temp. Oh, that's not working. And then I have another program which demonstrates interrupts using this joystick. Anyway, just a quick summary. Basically, the students, they all receive this, and then they do a a semester of lab work with it to figure out how to use a microprocessor and use different devices with it. And then down there, if they have any issues with it, they can always send me an email, and I help support them with their use of this in class. And the final thing I just wanted to go and show you, if we go to GitHub, let me go to my account. Oh, focus. I have some documentation on here to help explain this and the different things it can do, and how to how to set the switches if you want to do something, how this is wired, how that's and then I put all the Gerbers in there, and I told them that I made it with KiCad. Yep. And of course I have all the schematics and projects in here too. And that's basically it. Thanks for watching.